Welcome back to MathandBolt. In today's session, we will be working on 5 problems based on separation of variables. Problem number 1. So here we are provided with a differential equation, derivative of y with respect to x plus 2x is equals to e raised to the power of 3x. Rewriting this equation, we get derivative of y with respect to x is equals to e raised to the power of 3x minus 2x. Now separating the differentials, we get dy is equals to e raised to the power of 3x minus 2x multiplied to dx, and this is now in the separable form. What we're going to do is integrate both sides, which will give us integration of dy is equals to integration e raised to the power of 3x dx minus 2 times integration of x dx. So finally we get y is equals to integration of e raised to the power of 3x will give us 1/3 of e raised to the power of 3x minus 2 times integration of x dx will be x squared over 2. So the 2 and 2 gets cancelled, leaving us with x squared plus c, and this is the required solution to the given differential equation. Problem number 2. So here we have the differential equation x squared plus 1 times derivative of y with respect to x equals to 1, or it can be rewritten as derivative of y with respect to x is equals to 1 over x squared plus 1. Separating the differentials, we get dy is equals to dx over 1 plus x squared. Now we are going to integrate both sides. Now from the table of integrals, integration of dx over 1 plus x squared will be tangent inverse of x. So finally we get y equals to tangent inverse of x plus c. And this is going to be the required solution to the given differential equation. Problem number 3. We have the differential equation x plus 2 times derivative of y with respect to x equals x squared plus 3x plus 7, or simply dy over dx is equals to x squared plus 3x plus 7 divided by x plus 2. Separating the differentials gives us dy is equals to x squared plus 3x plus 7 over x plus 2 multiplied to dx. Now we're going to divide the numerator x squared plus 3x plus 7 by the numerator x plus 2 by the method of long division, and that should give us x plus 1 plus 5 over x plus 2, such that when we integrate both sides we get integration dy is equals to integration x dx plus integration dx plus 5 times integration dx over x plus 2. Integration of dy will be y, which will be equals to integration of x dx, so that is x squared over 2 plus integration of dx will be x plus 5 times integration of dx over x plus 2 will be natural log of x plus 2 plus the constant of integration c, and this is going to be the required solution to the given differential equation. Problem number 4. So here we have the differential equation derivative of y with respect to x equals 1 minus cosine of x over 1 plus cosine of x. Separating the differentials, we have dy is equals to 1 minus cosine of x divided by 1 plus cosine of x times dx. Now since this is in the separable form, we're going to integrate both sides. Now we're going to use the identity 1 minus cosine of x is 2 times sine squared x over 2. So we replace it with this particular value divided by, we have 1 plus cosine of x, which will get replaced with 2 times cosine squared x over 2, so that we get tangent squared x over 2. Now tangent squared x over 2 can be also rewritten as secant squared x over 2 minus 1. Here we're using the identity 1 plus tangent squared of theta is equals to secant squared theta. So we get integration dy is equals to integration secant squared x over 2 dx minus integration dx. So integration of secant squared function will be tangent function. So we have 2 times tangent of x over 2 minus integration of dx, which is x plus c. So therefore this is going to be the required solution to the given differential equation. Problem number 5. So here we have the differential equation, derivative of y with respect to x is equals to tangent inverse of x. Separating the differential gives us dy is equals to tangent inverse of x times dx. Now we're going to integrate both sides, so we have integral dy is equals to integration of tangent inverse of x dx. Now here we're going to consider tangent inverse of x as the first function and 1 as the second function, and integrating by parts we get tangent inverse of x multiplied to integration of 1 dx minus integration of derivative of tangent inverse of x with respect to x times integration of dx whole integrated with respect to x, which gives us x tan inverse of x minus integration derivative of the inverse tangent function will be 1 over 1 plus x squared times integration of dx will be simply x and whole integrated with respect to x. Now in order to integrate the second integral, we're going to multiply and divide by 2 so that we can use the method of substitution, and that should give us finally x tangent inverse of x minus half times natural log of 1 plus x squared plus c.